All right, my children, we are on page 37. We are starting a new unit, gas laws, and we're going to start by talking about measurements with gases. Temperature. I know in your life you've always thought about temperature as being a measure of heat, but in chemistry we learned that's not actually true. Heat and temperature are two different things. I know. I'm going to blow up your mind right now. Heat and temperature are two different things. Temperature is not a measure of heat. Heat is a type of energy. Temperature is a measure of the average amount of kinetic energy, which is a different kind of energy than heat is. Heat is a type of thermal energy. Temperature actually measures the average kinetic energy or movement of all the particles together. It's measuring how much motion the thing that you're measuring the temperature of is undergoing. So when you take your temperature, you're actually measuring the average amount of motion that the molecules and the atoms in your cells are doing. Our variable for temperature is a capital T. It has to be capital. The unit we use is the Kelvin, which is abbreviated with a capital K. We'll talk more about Kelvin on the next page. Volume is the amount of space all the particles take up. For a gas, basically your volume is the same as however big the container that all the particles are in. However big that container is how much your volume is for a gas. Our variable for volume is a capital V, and we measure it in liters. Pressure is the amount of force being applied to a given area. Basically, how hard are the particles going to collide with or hit the container's walls. So gases are always bouncing around. Bounce, 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 bounce. Gases are bouncing all the time. And every time they hit the wall of their container, that is what is applying pressure to the container. So if you think about like your tire pressure comes from the gas particles inside the tire hitting the edge of the tire as they're bouncing around all the time. Pressure, we use capital P as a variable, and there are actually three different units of pressure: atmospheres, ATM, kilopascals, kPa, and millimeters of mercury, mm for millimeter, Hg for mercury, because if you look at your periodic table, mercury is Hg. So mmHg, that's millimeters of mercury. Three different pressure units. We'll come back to those as well. We also measure quantity of gases using how many particles there are in the container if you counted them one by one. And we're going to count them not specifically one by one. We're going to actually count them in moles. And our variable we're going to use as a lowercase n for number of moles. N for number of moles. Yeah, moles are back. Like I said, they're never leaving. We're doing moles forever for the rest of the year. Kinetic molecular theory of gases. We assume that particles in a gas are blank because of the blank molecular theory. Well, we assume that this is called the kinetic molecular theory. The word kinetic refers to kinetic energy, which we talked about up here. Kinetic energy is motion. So we assume that the particles in a gas are moving because of kinetic molecular theory. Kinetic molecular theory has 5 postulates. You should know the word postulate from geometry. It basically means 5, we'll go with 5 ideas. First, gas particles are very small in comparison to the large distance between them. That is, particles of a gas have low volume, although the gas itself takes up a lot of space because the pieces are so far apart with emptiness between them. So a single gas particle is very, 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 very small, but the gas overall takes up a lot of space because all these gas particles have a lot of empty space between them. So most of the volume of a gas is empty space. The volume of a gas is mostly empty space. When gas particles collide with or hit the side of their container, the collision exerts pressure on the side of the container. Energy is conserved between colliding particles. You'll talk about that more when you take physics, energy being conserved in a collision. For now, what we're just going to say is that when the gas particle hits the edge, that causes pressure. So right there, that collision put pressure on the container. Down here, this collision puts pressure on the container. Okay, up here, this collision puts pressure on the container. Every time it hits the wall, that's what pressure is. And when they hit the wall, they bounce off and they keep going with the same speed that they were going before. That's what we're going to simplify this idea. Energy is conserved between colliding particles. We're going to simplify that to mean they go with the same speed after they hit the wall. But it's a little more complex than that. You'll talk about it in physics. Our third postulate, gas particles are in constant, rapid, random motion. They are always moving. They never stop. Can't stop, won't stop. Okay, gas particles can't stop, won't stop. Fourth postulate, gas particles do not attract or repel each other. They don't care about each other at all. Okay? They have no attraction to each other. They have no repulsion. They just don't care, like the shruggy. And the average kinetic energy of a gas is equal to the temperature of the gas. If you have low kinetic energy in your gas, that means that's going to be a low temperature. If they have more movement, then the temperature will be higher. I'm going to tell you right now, you have to memorize these 5 postulates. They will be on quizzes and tests. So I'm telling you right now on the first real page of the unit, you're going to have to memorize these. They will come up on your quizzes and tests. Don't complain about it when I tell you about it later, because I'm telling you about it right now. Let's look at the top of the next page, 38. Turn the page. Let's talk about temperature conversions. We're going to use the Kelvin scale for temperature. This is a scale based on the Celsius scale, but it has no negative temperatures. This is because the Kelvin scale sets 0 at the lowest temperature that can exist, which is called, you may have heard of it, absolute zero. Remember that temperature is a measure of motion. So there's no such thing as negative motion. If you the least motion you can have is 0. There's no such thing as negative movement. So if you have absolutely no motion, then you are at the temperature absolute 0, because there is absolutely no motion there, and temperature is a measure of motion. So what they did for the Kelvin scale is they took the Celsius scale and they basically bumped it back to where 0 on the Celsius scale is the freezing point of water. They just bumped it where instead they're making 0 the point where there's no movement, absolute 0. So now there's no negative numbers. Please notice this is a pet peeve of mine. The abbreviation for Kelvin is just a capital K. Don't put a degree sign next to the Kelvin K. It's not degrees Kelvin, it's just Kelvin. So when we go to convert between Kelvin and degrees Celsius, Kelvin is Celsius plus 273, because absolute 0 in the Celsius scale is roughly negative 273. We just pulled it back to where we put 0 Kelvin, the same as negative 273 Celsius. So if you have Kelvin, if you want to find Kelvin, you do Celsius plus 273, or if you want to find Celsius, you do Kelvin minus 273. So I'm gonna do 2 of these practice with you, and you'll do the other 2 yourself. Convert 25 Celsius to Kelvin. Well, if I want to find Kelvin, I take Celsius and I add 273. So that's 298 Kelvin. Okay, I'll also do number 3 with you. It says convert 300 Kelvin to Celsius. If I want to find degrees Celsius, I do Kelvin minus 273, so 300 minus 273, and that is 27 degrees Celsius. and you should try number 3 and 4 yourself. Gas laws. We have several laws, mathematical laws, that tell us how gases are affected by changes in pressure, volume, temperature, and amount of particles, or we'll just simplify that and say amount of moles. All these 3 laws are named after some dudes. Boyle's law is named after Mr. Boyle. It keeps temperature and moles constant, and it says that if pressure increases, volume decreases. There's an equation for that. P1 times V1, there's times here, these are times, equals P2 times V2. So pressure and volume are inversely or indirectly proportional. What does that mean? Inversely or indirectly proportional. You should know this from your math class. It means that if one goes up, the other goes down. If one goes up, the other goes down. Charles's law keeps pressure and moles constant and says that if volume increases, temperature increases. The formula is V1 divided by T1 equals V2 divided by T2, so that volume and temperature are directly proportional. Which means that if one goes up, the other goes up. If one goes down, the other goes down. They either both go up or both go down. And the last one, gay-Lussac's law, keeps volume and moles constant. The relationship is between pressure and temperature. If pressure increases, temperature increases. So P1 over T1 equals P2 over T2. Pressure and temperature are directly proportional. When you're done writing that, turn the page. I have a trick to show you to know how pressure, temperature, or volume will react to changes. I hope you are watching me as I explain this. You should actually be looking at the video right now as I explain this. Here's how this works. If you're reading a problem, and the problem says, like, if temperature is held constant and pressure goes up, what happens to volume, or something like that. Here's what you do. You put your pen on the one that's constant to hold it still. So like if the question says temperature is constant, okay, I'm going to put my pen on temperature. Temperature is constant, and I'm going to use my pen to hold temperature in place while I move my paper around it. So I'm going to pivot the paper around where my pen is holding temperature in place. Okay, so if pressure goes up and temperature is constant, I'm holding temperature still and constant with my pen, and if I make pressure go up, I've literally raised it on my page. What happened to volume? It moved down. Okay, I'll do it again. If I turn my page so that pressure goes up, volume goes down. If temperature is constant, and I want to know what happens to pressure if volume goes up, well, if I move my page where volume goes up, the pressure goes down. This works for others as well. If instead if I'm holding pressure constant, I hold it still with my pen, I want to know what happens to volume if temperature goes down. Well, I moved temperature down and volume also went down. If I want to know what happens to temperature if volume goes up, I move my page so that volume goes up and temperature also went up. Okay, and that works if you're holding volume constant. If volume's constant and I want to know what happens to pressure if temperature goes up, if I move temperature to go up, pressure is also going up. If I hold volume constant and I want to know what happens to temperature as pressure goes down, I move pressure down, temperature is also going down. So this trick can help you decide what's going up and what's going down. The thing you have to make sure you do is that you have to write them in alphabetical order, P, T, V. They have to go in order, P, T, V. If they're not in order, then your trick's going to not work correctly. It's going to lie to you. We also need to talk about standard temperature and pressure. For purposes of comparison, scientists have agreed on standard conditions for experiments with gases. These are listed on your formula chart, which is at the back of your book. Right, if you look at the inside of your back cover of your book, okay, on this formula chart, it says STP, standard temperature and pressure, 0 degrees Celsius, 1 atmosphere of pressure. So this means that if you have standard temperature and pressure, that means T is equal to 0 degrees Celsius or 273 Kelvin, and that means that P is equal to 1 ATM. There will be problems, both in your book and on quizzes and tests, potentially, that just say STP, and they expect you to look at your formula chart and know that T will equal 0 degrees Celsius or 273 Kelvin, and P will equal 1 ATM. Okay, for a video on calculations, you're going to have to go to the next video to see some practice calculations.